Question 10. Mariam wants to invest £4,000 for 2 years in the same bank. So she wants to leave the money in the same bank for 2 years. She doesn't want to take it out of one bank after 1 year and take it to another bank. So the first bank, the online bank, will offer her compound interest. So they'll give her 5% for the first year and 2% for each extra year. So for our question, the second year she'll get 2%. And the digital bank, they'll give her 6% for the first year, and every other year they'll give 0.4%. Now, as you can see in the first bank, they give 5%, which is less than 6% in the first year. At the end of the 2 years, Mariam wants to have as much money as possible. Which bank should she invest her £4,000 in? So, for the first bank, the online bank, the calculation would look something like this: £4,000, because that's how much she started off with, times by 1.05, because the first year the interest rate is 5%, and the decimal multiplier for 5% increase is 1.05, and the second is 2%, so the decimal multiplier for 2% increase is 1.02. So if you do that in your calculator, you'll get the answer £4,284. So £4,000 times 1.05 times 1.02, which is the interest rate, was 2% for the second year. And as you can see, on the second year, you get, at the end of the second, you get £4,284, which we've written down already. So for the second bank, the digital bank, the calculation would look like this. So we started with £4,000, then because the interest rate was 6%, so we times by 1.06, and then the second year the interest rate was 0.4%. So the decimal multiplier for 0.4% increase is 1.004. So once you do that in your calculator, you get the answer £4,256.96. So as you can see, so 4,000 times 1.06 times by 1.004, and that gives us the answer of £4,256.96, which I've written down here. So looking at the two amounts, I can see that this amount is larger, so I would invest her money in the first bank, the online bank. So would invest in this one here. I just want to quickly explain how did we get this decimal multiplier of 1.004 for a 4%, 0.4% increase. So obviously we started off with 100%, that was the £4,000. Then we're going to get another 0.4%. Now if you add the 100% to 0.4%, so all of this added together would be 100.04%. So how do you turn a decimal percentage into a decimal? You have to divide by 100. So 100.4 divided by 100 is 1.004. That's why the decimal multiplier here is 1.004. Just to explain in a bit more detail, so we had 100.4, which we want to divide by 100. Now when you divide by 100, the decimal, the digits will move one digit to the right if we divide by 10, but because divided by 100, we want to move another place to the right, and so you get 1.004. So just want to explain that one more time. So we start off 100.4. If we divide by 10, all the digits move one place to the right, the decimal stays in its place. So you get 10.04, that's dividing by 10. And then if we divide by another 10, we get 1.004. So that's the same as saying 100.4 divided by 100 is 1.04. And that became our decimal multiplier. Question 11. Adam bought a new car. Each year the value of the car depreciated by 8%. So depreciate means the value went down. Okay, as you get older, most things, mobile phones, tablets, laptops, cars, vans, they go down in price. So it says now calculate the number of years after which the value of the car was 51% of its value when new. So they haven't told us how much the original value when the van was new. So we'll just call that x, so x pounds. Then it tells us that it depreciated by 8%. So remember, if the original is 100%, it went down by 8%. So that means we've got 92% left. So our decimal multiplier would be 0.92. Now we don't know for how many years, so we'll just write that as n to the power of n. If we knew it was 6 years, we could have just written 6. If it was for 7 years, we could have just written 7. But we don't know, so we leave it as n. And then it tells us in the question that it has to become 51% of its original value. So x was its original value, and if you want to find 51% of something, you just times it by 0.51. So looking at it initially, it looks like there's a problem. We have two unknowns. We have an x and an x here, which is unknown, and we have an n here, which is unknown. We can't really have two unknowns. But luckily, if you look here, we are doing times x here, and we're doing times x here. So luckily, this can cancel out with this. So when you cancel that out, you'll be left with 0.92 to the power of n should equal to 0.51. So remember, whenever you don't know the number of years or n, you have to do trial and improvement. So I'm going to guess something like 4 years. So we can do 0.92 to the power of 4, and we want it to be equal to at least 0.51 or close to 0.51. So on my calculator, I'm going to 0.92 to the power of 4, and the answer is 0.71. But remember, we want this answer to be closer to that. So we have to try a slightly bigger number. So 0.92 to the power of 4 didn't work. So we're going to try 0.95. So as you can see, I've now tried to the power of 5, and I got the answers to be 0.659. So that is still not as low as 0.51. So we're going to have to try it to the power of 6. So as you can see, even with 0.92 to the power of 6, this answer still isn't as low as this. So now we're going to try 0.92 to the power of 7. And as you can see now, with 0.92 to the power of 7, we've got the answer 0.558 to 3 decimal places. So this is now getting closer, but still not as low. We need to get even lower. So as you can see, with 0.92 to the power of 8, we have finally got the answer to be 0.5132. On the calculator, you can see that 0.5132. And at last, it is below the 0.51 that wanted to be, or close to 0.51 that wanted to be. So it would have taken 8 years for his investment to reach 51, or the value to reach 51%. So as you can see, they didn't tell us what the original value of the car was, so we called it just X. Then because it's 8% depreciation, the decimal multiplier was 0.92. We don't know how many years, so that's why we had to do all this trial and improvement. And they told us they had to reach a value of 51% at just 0.51. So as you can see, we had to work out by repeated trials that it would take 8 years for it to reach 0.51, 51%. So the answer is 8 years. So whenever you don't know the number of years, the n years, okay, you have to do this trial and improvement and work out your answer. And you've got to show all of this working out. And it was quite fortunate that we were able to cancel out here and here. Those would have had another unknown. So the original value doesn't matter. Okay, whatever it was, because it's times x here and it was times x here, so we cancelled out. If you didn't understand this, you have to go to the beginning of the question and go over it again. It is a bit tricky, but if you watch it again, hopefully it will make more sense. Question 12. Asia invests £600 on the 1st of January 2010 at a compound interest rate of Z%. So they haven't told us what the interest rate is, Z% per annum. The total value T of this investment after n years is given by the formula below. So we don't know how many years, so just call it n years. So we don't know how many years, so to the power of n there. The question then says, what is the value of Z? Basically, what is the interest rate? So I can see in the bracket it says 1.032. Now that's a decimal multiplier. How do you turn this decimal into a percentage? You've got to times it by 100. So if you do 1.032 and you times it by 100, the answer would be 103.2%. So originally would have had 100%, and to that you're adding another 3.2%. So the interest rate Z is 3.2%. So if we work backwards, say for example, they told us that the interest rate is 3.2%. What would we do? We'd do 100 plus 3.2 is equal to 103.2, and then we do 103.2 divided by 100, and that would give us 1.032, which is what we have here. So can you see, working backwards, we've just shown that in fact it is 3.2%. So Z, the interest rate Z, or this figure here, is 3.2%. It's quite a good question because it helps you to think about what this value here means. So I just want you to think about this bit here in a bit more detail. So remember, I told you if I knew the interest rate was 3%, I would do 100 plus 3.2, which would give me 103.2. Then I would do 103.2 divided by 100, and that would give me the decimal multiplier is 1.032. So for this question, we essentially had to go backwards. So the first thing we had to do is instead of this divided by 100, we're going to do times by 100. So 1.032 times by 100, and that gives us the 103.2, which is this here. And then remember we added 100, so this time we're going to take away 100. So 103.2 minus the 100 gives us 3.2%. So we had to go backwards. So normally they tell us the interest rate and then we turn that into a decimal multiplier. But this time we're going backwards. We've got the decimal multiplier and we're going backwards to find out what the interest rate was.